its way to our new daily life, and most of it is helpful and make life easier. Biometric attendance system is such a machine which has brought more precise system to measure group or individual activities and attendance as well. Automated attendance system is the best replacement to bulky, time-consuming manually fed attendance system. There are various automated attendance systems available, but most of them uses LAN or storage devices to extract and access data. Features: biometric device is completely wireless. It is a portable device which can be carried easily. Instant confirmation is obtained. Consumes less time for detection of finger. Centralized control is provided along with the high security.
This is our biometric module. It consists fingerprint sensor which takes fingerprint and stores in 2 character buffers, each of 512 bytes present in it. Later, stored template can be processed further. This fingerprint sensor has embedded processing unit. This is LCD display. Displays the process that microcontroller is undergoing. This is RF module, which consists of RF transmitter and RF receiver. RF transmitter consists of encoder IC, which encrypts the data and sends to a central embedded server. RF receiver consists of decoder IC, which decodes the data received and sends to microcontroller. We are using 89B51 RD2 microcontroller, which is an NXP microcontroller, which has one specialty, that is inbuilt programmer, and it is a DIL package. A switch is being used to start the process of attendance. Now this is our second module, that is Central Embedded Server. It consists of RF module, RS-232 for serial communication with PC, and NXP microcontroller 89B51 RD2. This is used to communicate with the fingerprint module, and it is connected to the central server, that is computer or laptop.
Before starting the class, lecturer gives his fingerprint to start the process of taking attendance. Later, he or she will hand over the device to the students. All the students, one after the other, will give their attendance by giving their fingerprints. After all the students finishes giving the attendance, lecturer will give his or her fingerprint once again to stop the process. The data is sent to central embedded server instantaneously. Hence, central server can do further process like storing, updating in web page using PHP or some other software.
Now let us see the working of our fingerprint biometric module. Now we have already enrolled these fingers. This finger as lecturer, this as student 1, student 2, student 3. Now let us see how it works. When lecturer presses the button and gives his fingerprint, finger is scanned and lecturer found it as lecturer start. The data is transmitted wirelessly. You can see this LED blinking, and this 601, 6 is command, which means lecturer started the class. 01 is the lecturer ID, lecturer's unique ID. Now student 1 is going to give his attendance by giving his fingerprint on the fingerprint module. He presses the button. His image is taken and image is found because it is already registered. Student attendance is marked. His ID is 21. Data is transmitted. 5 means student has given his attendance. 21 is the student ID which you have seen on this LCD screen. Now student 2 is also going to give his attendance. Image is taken and it's found. Student attendance is marked. Once again transmitted wirelessly, and here you can view 5, as you know, it's command, and 22 is the student ID. Student 2 ID. Now similarly this process continues. Student 3 gives his fingerprint, nothing but attendance. Attendance is marked. His ID is 23. It is transmitted and then you can view on this hyperterminal. 23 is his ID, 5 is command. This hyperterminal we have used just to show the output. Now let us stop. When class finishes, lecturer once again gives his ID. Then it checks for the ID and gives a message, lecturer stop. And it is sent to the server, which is displayed on the hyperterminal. 01, as you know, this is lecturer ID who had started the class. 7 indicates the class is over. As you have seen, this 6 started the class, 7 stopped the class, and these 5 were students' attendance marked. Now I will show you how to enroll. I will give an input 1, 0, 1. Command is 1, ID is 1, add lecturer. So now I am going to put finger. First image is generated. Second image is also generated. Storing success. Yeah, it is completely enrolled. 0. This 0 means an acknowledgement has come from fingerprint module to the central server. 101. 1 is for add lecturer. 1 is a command and 01 is the ID of the lecturer. Now I will show you how to add student. 3 is the student command and next 2 digit is the student ID. Now I give 3, 2, 1. You can observe here command is 3, ID is 21, add student. So put finger. First image, second image also taken. Enroll success, ID is 21. You can view on hyperterminal the acknowledgement as 0. Now once again similarly we can enroll many students. 3, 2, 2. Student ID 22. You can see here command is 3, ID is 22. Enrolling. Yeah, let me put my finger. First image. The second image. Enroll success. You can see there acknowledgement is 0. It means enrolling is done. Now let us delete the stored fingerprint. I am giving 2, 0, 1. Command 2, ID 1. Deleting lecturer, deleting 1. 2 command is used to indicate to delete and 01 is the lecturer ID. In same way I will delete the stored fingerprint of a student. For student we have used 4, 2, 1. 2, 1 is the ID and 4 is the command. You can see here 4 is the command and ID is 21. Deleting 21, deleting done. Deleting can be done like this. And now I will show the errors. Like if this finger is not registered, so I will keep this finger and press the button. Finger is taken, but as this finger is not registered, so it shows no match found. If the registered finger is kept. If it is kept incorrect, then also you will get finger not found. Retry.
This one is the attendance main part in WBAS, which is Wireless Biometric Attendance System. We have used the Visa interface to communicate with the hardware. Whenever there is a fingerprint received at the WBAS system, it can be a lecturer fingerprint or a student fingerprint. If it is lecturer fingerprint, a lecture session is started and we get a packet corresponding to that. If it is student fingerprint, attendance packet is sent if lecture is going on. Once lecture is over, lecturer is supposed to put fingerprint one more time so that lecture will be stopped. So wirelessly packets are transmitted and we received over a PC which is having a RF receiver and transmitter, which converts that received packet into serial packet and sends to our PC LabVIEW program. In our LabVIEW program we have used three main things, which are Visa interface for serial communication, string handling and file handling for storing the student attendance database. We have used COM1 for communication for the Visa interface via hardware to LabVIEW. It is 9600 baud rate, 8-bit, and this is a Visa read VI. We are using 5 bytes packet, so it will use 5 bytes and give to this buffer. It will show the packet received in the buffer and it will close the Visa. This output is going to a string pattern matching VI. We match a pattern here. Once pattern is validated, it will stop this while loop and go for string parsing. Using string parsing, we find out which kind of packet it is, whether it is lecture start, lecture stop or student. If it is a lecture start, it is a 6th value packet and we have already opened a file here. The file name is attendance.txt, and then we go to the end of the file because always we are appending our database, and we write a string start lecture followed by ID, then followed by date and time. This is a timestamp VI. All strings are concatenated using this concatenated VI and write to the file using a file write operation. Then there is some delay and we go for the next frame. Again it will wait for the next packet to come. Suppose it has come a student packet, student attendance packet, so it will go in case structure 5. So case structure 5, what we see here is this is attendance packet. So we have a dialog box also at every different places to show us what is happening in our system. That dialog box can be removed afterwards once system is finalized. So again we have here a packet parsing. We parse the string and extract the ID from it, and that ID plus attendance value is written in the file at the end of the file. So here this database is slowly built. As the packet comes, this database will be built of the student attendance database. After lecture is over, we give the packet type of 7, which is a stop lecture thing. So we again go to the end of file, write stop lecture along with the calories written, and then we exit the things are our output is file handling and our only getting exited automatically. So I'll show you the file which is generated by our system. This is the empty file attendance.txt. As soon as the packet starts coming, this file will get filled. We are expecting a start lecture packet from the WBS system. So you can see the read buffer is 611. 6 is the packet type start lecture, and we have got 2 dialog boxes also. This is a packet dialog box and this is a packet identification dialog box. So it is a 611 packet and start lecture. Now we will see our file status, whether something is written in our file properly or not. So we can see here a start lecture, lecturer ID, date and time, everything is written in the file automatically by this LabVIEW VI. I'll close the file and I'll go for the next packet, which is the student attendance packet. So here it comes the student attendance the student ID is 21. So you can see the packet is 521. Now we'll wait for more students to give their attendance. So the student ID 31, student ID 25, student ID 40. Now I expect one lecturer to stop his lecturer. So this packet is 711. So is a stop lecture. We can exit on this packet receive, or we can continue also depending on the application. Now we'll check our file. So you can see it is automatically created file by LabVIEW software. So start lecture, these are the lecturer student attendance, and stop lecture. When a new session starts, again this file will keep on growing automatically.